Today we are going to discuss the question I passed to you last lesson. The question sounds like this. Show that the equation x to the power 3 minus 5x plus 1 equal to 0 has a real root in the interval 0 and 1. The iterative formula derived from the above equation can be written into the form Sn plus 1 equal to cubic root 5xn minus 1, or xn plus 1 equal to 1 over 5 bracket xn to the power 3 plus 1. Show that only of these formula can be used to find the root using initial value of x equal to 0.5, and hence determine this root correct to 4 decimal place. We can divide the question into 3 parts. The first part, we use the intermediate value theorem to solve the question to show that the equation has a real root in the interval 0 and 1. The second part, we derive the formula or iterative formula from the equation given. The third part, we are going to find the root using the initial value 0.5 to find the approximation root. Part 1. Show that the equation x to the power 3 minus 5x plus 1 equal to 0 has a real root in the interval 0 and 1. So I apply the intermediate value theorem to solve it. First step, I let the f of x equal to x to the power 3 minus 5x plus 1. Then I substitute the value 0 to get the value for f of 0 equal to 1. This is a value greater than 0, so there's a positive sign. Then I substitute s equal to 1. For f of 1, I get the value is negative 3. It's less than 0, so it's at the negative sign. So since we know the f of 0 and f of 1 have different signs and f is continuous function, so there is a root between 0 and 1. Second part, from the equation given, we have to derive a iterative formula in the form xn plus 1 equal to cubic root 5xn minus 1, or xn plus 1 equal to 1 over 5 bracket xn to the power 3 plus 1. To derive the iterative formula xn plus 1 equal to cubic root 5xn minus 1. For the working solution, first I let the f of x equal to 0. So the equation given is x to the power 3 minus 5x plus 1 equal to 0. So I compare it to the iterative formula you want to derive, that have cubic root. So I pin the x to the power 3 at the left side, and all the variable and the constant, I bring it to the right side. To change the x to the power 3 to x, so I multiply x to the power 3 with 1 over 3. And same as the function 5x minus 1 bracket, I also multiply the power with the 1 over 3. So now I have the x equal to cubic root 5x minus 1. So the formula can be written into the iterative formula xn plus 1 equal to cubic root 5xn minus 1 shown. Another iterative formula you want to show is xn plus 1 equal to 1 over 5 bracket xn to the power 3 plus 1. So we do as previous working solution we did. So we let f of x equal to 0. So we have the x cubed minus 5x plus 1 equal to 0. So before we continue with the further working solution, we compare the equation to the iterative formula we want to derive. So they have a 1 over 5 outside the bracket. So I bring the 5x at the left hand side. And other than 5x, I bring it to right hand side. So become 5x equal to x to the power 3 plus 1. We want to obtain x from 5x, so we divided the 5x by 5. So same as the left side, the right side also we divided the function by 5. So we get the answer x equal to 1 over 5 x to the power 3 plus 1. So we rewritten it into the iterative formula. So become x n plus 1 equal to 1 over 5 bracket xn to the power 3 plus 1. How to determine the iterative formula we got from the previous working solution is convergence or divergence. The conditions must be satisfied is the modulus of the first derivative for iterative formulas must less than 1. Two iterative formula we derive from the equation given. The first one, cubic root 5x minus 1. So we do the differentiate the function with respect to x. We have f prime x equal to 5 over 3 bracket 5x minus 1 to the power of negative 2 over 3. Then we substitute the initial value 0.5 into the equation. We obtain the answer is 1.272. So f prime 0.5 is greater than 1. Then we conclude that the iterative formula cubic root 5x minus 1 is divergent sequence. For the second iterative formula is 1 over 5 over bracket x to the power 3 plus 1. So we differentiate the function or the iterative formula with respect to x. We have 3 over 5 bracket x to the power of 2. We substitute the initial value 0.5 into the equation. We get the answer is 0.15. So f prime 0.5 is less than 1. So we conclude it as convergent sequence. Therefore, the iteration x n plus 1 equal to 1 over 5 bracket x n to the power 3 plus 1 is more likely to give a convergent sequence of approximation to a root in the interval 0 and 1. Last part, we want to find the approximate value of the root by using the initial value equal to 0.5 into the iterative formula x n plus 1 equal to 1 over 5 bracket x n to the power 3 plus 1. So when n equal to 0, mean we apply the initial value 0.5. So we find the first approximate value equal to 0.225. So when n equal to 1, we have the second approximation value. Now we sub the x1 equal to 0.225 into the equation. The second approximation value is 0.2023. We do the same process to calculate the value of approximation value until we get the value of the root is 0.2016. So we can do the conclusion that the root of the equation x to the power 3 minus 5x plus 1 is 0.2016, correct to 4 decimal place. Do the exercise yourself. Show that the equation x to the power 4 minus 2x to the power 3 minus x plus 1 equal to 0 has at least a real root in the interval 2 and 3. Determine which of the iteration xn plus 1 equal to xn to the power 4 minus 2xn to the power 3 plus 1 or xn plus 1 equal to 2xn to the power 3 minus 1 over xn to the power 3 minus 1 is more likely to give a convergence sequence of approximate to a root in the interval 2 and 3. Use the choice with initial value x equal to 2.5 to determine the root correct to 3 decimal place.